Ambassador for Hyderabad chapter. WITS is all about inspiring and encouraging and educating more women in the field of data science. And why more women in the data science is we all know that most of the critical decisions in any organization or institution are made by analyzing a lot of data, and the team that is involved in making those analysis and taking those decisions should be diverse, and hence WITS. So it all started in 2015 at Stanford University with one single conference. But after 7 years, it has become a movement with more than 200 plus conferences in 90 plus countries and 500 plus ambassadors hosting the same. And I'm so glad that today we are hosting the third edition of WITS Hyderabad conference. We also started off with one conference in 2020, but we have also signed up with other initiatives of WITS like Datathon, WITS Datathon. We've done it last year and we've signed up this year as well. And we have WITS Story where you'll get to, it's a blog where you'll get to read the wonderful stories of all those women who are inspired by WITS. And we also have WITS Education Outreach Program that was launched 2 years ago to inspire high school girls to stick or to take up STEM courses. And we at Hyderabad, WITS Hyderabad is the first region in India where WITS Education Outreach Program was brought to a high school at Vishnu School in Bhimavaram, and it was launched there, piloted there with 60 students, and the program was really a major hit. Then we have WITS podcast also that WITS Hyderabad has not ventured into, and we are looking forward to contribute to the WITS podcast as well. Now, without delaying further, I would like to play the opening video of WITS from Stanford University.
Data-driven decision-making is at the heart of so much in the world right now. We're making decisions not just for us now, but for future generations as well.
You know, the connection to data science is becoming more and more important to the work. The work has been going on for the last 25 years.
So what really drives us at WITS is that we want diversity at the decision table here. And women absolutely need to be there.
To me, a healthy data science community is one that embraces diversity.
We started WIDS with a conference at Stanford University in 2015 with three main goals that haven't really changed. First, to inspire women to join or stay in the field of data science. Second, to educate everyone by highlighting fantastic women and their technical work. And third, to support women around the world.
And wow, did we hit a nerve we didn't even know existed. Fast forward to 2022, and we have 200 regional events worldwide in more than 60 countries. And it just keeps growing year after year.
Last year, we were with all of you virtually. We had a 24-hour around the world event, which was very exciting. And so despite the pandemic, we got together and we created this global community. We had speakers from over 25 different countries, and it was wonderful.
And one silver lining in an otherwise tough year in 2021 is that attendees to WIDS regional events could be from anywhere in the world. We also saw really interesting collaborations, WIDS ambassadors coming together to host events in Africa, Saudi Arabia, Colombia, and Central and Eastern Europe.
One of the things I really love about WIDS is hosting the WIDS podcast. And we now have listeners from over 160 countries, which is just incredible, and many different guests. And I'm also really excited to announce that we'll soon have a co-host of the WIDS podcast, Cindy Orozco.
We also had amazing participation in the WIDS Datathon this year. Over 4,000 registrants in the Datathon from over 90 countries participating in a challenge related to climate change. And a big shout out to all the WiDS ambassadors who held workshops. We had over 40 workshops across the world.
I hope we also lift our heads above the horizon and think more than just about this moment in time, and think about the goals that we have for our young women and our young girls who'll be leading the next generation.
With the WiDS Education Outreach Program, which is focused on secondary schools, we've delivered materials to collaborators in over 50 countries around the world. We've had a great year despite all the challenges in the schools with COVID. We've had pilots everywhere from Covada, India, to New Haven, Connecticut, to a refugee camp in Jordan and beyond.
New last year were the WiDS workshops, where instructors provided dozens of workshops that were attended by thousands of attendees worldwide, online.
These WiDS initiatives would not be possible without the generous support from our sponsors, the global visionaries, the innovation leaders, and everyone at Stanford.
One thing we've been very excited about this last year is working on what we call the WiDS Academy. We got interested in understanding better what the barriers were for young women and for minorities to enter this exciting field, and how we could possibly remove those barriers, and what sort of programs could we put in place with partners all over the world to help.
Our ultimate aim with WiDS is to increase the percentage of women in data science, to achieve at least 30% women across all domains and at all levels, from students to senior leaders, by the year 2030. And we call this 30 by 30. We believe 30% is a tipping point. That's when women truly believe that they are part of a group and they can contribute and have great impact. And we hope that you join us all in reaching this big goal.
For now, though, whether you're at Stanford or at one of the regional events worldwide or just in your living room, you are a part of the WiDS worldwide movement.
Welcome to WiDS!
Well, that's the opening video from Stanford University for all of us. Now, without delaying any further, we will invite our keynote speaker today, Dr. Sudha, who is the Dean Faculty of Informatics, and she is the Director of Center of Excellence in AI and ML at Osmania University. She holds a bachelor's, master's, and doctoral degree in computer science. And apart from all of this, she's a vivid reader, and she holds a lot of focus in social service towards children. WiDS Hyderabad welcomes you, Dr. Sudha. Over to you.
Yeah. A very good morning to all the participants, the hosts, and all the student friends who have joined. Actually, it gives me immense pleasure to be a part of this Women in Data Science. This is really a wonderful program as showcased in the opening video. It's really heartwarming to be a part of this group of data scientists who share common aspirations, ideas, and goals. So firstly, a very happy Women's Day in advance. That's coming up. So although many data science-based approaches have existed for nearly 3 decades, okay, there has been a new resurgent interest now in applying all new solutions, new techniques for solving major problems, for decision making. So that is mainly because of the recent advances in cloud computing and making inexpensive storage and compute resources available to everybody. Now, before I go ahead, is my screen visible?
Yes, Dr. Sudha, it is visible.
The main, I think it's a wonderful topic that has been selected. And I think people are really interested in having this special core part of new developments that are happening across the globe. So it's a merger of computer science and IT, of maths and statistics, and business knowledge, the domain knowledge. And obviously, that is where data science is where machine learning, traditional research, software development, all of these meet together. Now, applying knowledge that has been gained in one area itself is pretty challenging. Now, you can imagine how interesting and yet how challenging that would be to be a part of data science, to be able to apply the maths and statistics, the algorithms that you would have learned to different domains, to different business areas. So that is actually being applied extensively in various diverse areas. It could be from structural analysis in civil engineering to transport and network analysis to remote sensing to control systems design, smart electric grid. There's a lot into financial fraud and risk management. And obviously, there's a lot into genome analysis, drug discovery, material strength testing, supply chain management. So you name it, it's across all verticals, across every domain. Today, we do have data science being applied, and really, there's a lot of return on investment that's happening. So obviously, everyone are keen to pick up what exactly is their return on investment or what exactly can they do with this data science. So participation in this kind of talks as are scheduled today will onboard our student friends in actually getting on to identifying where can they contribute to this domain of data science. Some of this, there could be people who are having excellence in terms of good programming skills. They would probably be able to collaborate with those who are good with mathematics and statistics and apply for solving various business areas. But obviously, as you know, there's this kind of skills, data science skills and data analytics skills, both would be required in the modern domain, in the modern industry, where the expectation is very high, the challenges are great. It's very interesting. At the same time, you should be able to showcase your skills far better than your competitors. So there's not only this business intelligence that was there sometime back, not only databases, not only data analysis that used to exist sometime back, but today there's a lot of interest towards how the huge data that is available, how can you actually get to know the deeper meanings or deeper understanding of how do these pieces of data correlate, how can they influence your decision making. So that is where it makes a lot of difference to have depth into various areas. Obviously, throughout the day, the experts would be talking to the participants about each of these various tasks that are done in data science processes. And they would probably, as I saw in the brochure, probably they would be explicitly talking about their domain. But broadly, this data science process consists of various aspects of various tasks, wherein data engineers, data analysts, machine learning engineers, all of them come into the picture. So that makes all of this so interesting. That makes it so wonderful that you are focusing on various aspects. It could be on data acquisition to data gathering, where today the interesting part is data need not be from one particular source. It need not be only audio, it need not be only video, it need not be only some kind of tables. The wonderful part is you have any kind of data and you have mechanisms, you have APIs by which you can translate this raw data into some kind of quality data. So you could have a real-time streaming data and you can put them into some kind of data lakes. So this multi-tenant resource allocation can be done at scale. So there is no limitation. Today, the wonderful part is why all this process of data science has really grown exponentially is because of the availability of cheap resources. It could be compute resources and storage resources that are available for use at much lesser cost as compared to what it was maybe say 10 years back and 15 years back. So the cloud service providers are enabling capture of this kind of data, storage, and in fact, a lot of APIs that are available so that you don't have to start writing the code for manipulating the data also on your own. Just call whatever is required through these APIs. But of course, not to belittle the entire task that goes into cleaning the data, sampling and estimating and managing with your unbalanced data and trying to actually identify what kind of a hypothesis will really help you in building that specific model. The challenge is not every model that you can build will solve all the problems. Similarly, whatever the models you build will fit all the kind of data that is available. So that is the interesting part. That is the point where there is a lot of challenge. Today, if we build some kind of a model for maybe predicting the sales of one particular organization or maybe in one vertical, obviously I can't be using that for another vertical. What is true for your sales and I mean sales of let us say in banking, that kind of return on investment that they are trying will not be the same for your manufacturing. It will also not be same for your warehouse management. So though the concept is same, again there's a lot of change that happens. So that makes it interesting to know what fits in where. So also the challenge today is that there is huge amount of data, humongous amount of data. But you should know, the challenge is we need to know how best you can use what particular part of data. That makes it necessary to get into details of understanding the data, trying to look at what makes a big difference. So that really is a very challenging part. So there are a lot of interesting aspects as to how do you look at the goodness of fit, or maybe what kind of linear regression or non-linear regression techniques you would like to use, what kind of forecasting models you would use, and so on. So in fact, though it looks pretty simple in our picture here, that model building itself is a very challenging and interesting task. So whether you use some kind of a classifiers or you use support vector machines or decision trees, in fact, there are a lot of techniques by which you could be using a collection of each of these, and that is like ensemble methods. So like we said, there are a lot of cases where you might not really be having labeled data. Raw data is available where you do not know what is to be classified into what. But there are techniques that are available today. So whether it is fraud detection, identifying the sentiment, or whether it is across various domains, whether it is into deep learning or transport, healthcare, e-commerce, manufacturing, banking, finance, it's so interesting and so challenging today that in one domain you could be talking of multiple ways of using data science. So there is a lot of research that's happening across the globe, and being into data science is the best thing that you could be doing at this particular point in time. So you could be working on self-driving cars on one end, and you could also be working with some kind of manufacturing domain. You could also be looking into banking and also into healthcare. So you name it. I mean, just idea is the stopping point, or it is only the limitation. And once you have an idea as to how you can implement this, then probably that is, I mean, one particular model that you build, one kind of a learning experience is enough for you to catapult your ideas into reality. So that is actually because of the availability of a lot of newer approaches of using deep learning, right? And accelerated AI, wherein the models that were available for normal deep learning are enhanced to a great extent by using TPUs and GPUs. So the great part of it is if you are work for one instance on one particular domain, if you have understood how you could be using deep learning and how you could be using TPUs, GPUs for enabling image processing so that it can be used for self-driving cars. Obviously, you could be using that kind of a image processing, in-depth analysis on TPUs and GPUs at a much faster rate, and use that kind of an application for e-commerce or for medical image analysis and so on. So these days, there is a lot of interest across various domains. Then the main motivating factor is we are seeing real-time results. The application of data science, application of machine learning, AI, a combination of all of this is really making a huge difference to various organizations. So once you look at the kind of investment, the capex and the return on investment, all of this, possibly there is more interest in enabling all of this for future. So that makes it necessary for our current generation, current students specifically, to get exposed to various tools that are available today. So there are a lot of tools like SPSS statistics, to Google Colab, to Python, to various other kind of text analytics and NLP related tools, which are really helpful in changing the scenario today. I mean, what exists today, tomorrow the student should be able to do it better. That is the expectation. So the student should be able to get an understanding of how this large data that is available can be used for training, retraining, for deploying, for scheduling, for monitoring, and actually improving these various models that we are trying to put up. So in order to do that, in order to get that optimal performance, what is required is enhancing the skill sets. So today, if you have learned only use of Apache Spark, that is not enough. So there is another tool that comes up which is better than this, and also explores, looks at the challenges that were there in this and takes it higher, takes it better. So there's a lot of need for research. There is a need for understanding the specific use cases and learning these various tools while they are students. So with one basic quote about how we need to be able to manage change, something that is very relevant to modern context. So decades ago, Charles Darwin had rightly pointed out, it is not the strongest or the most intelligent who will survive, but those who can best manage change. So change and challenges are inevitable. So what we require is all these various upcoming areas should get incorporated into the students' curriculum. Now, if that is to be done, I think there are responsibilities on us as practitioners, as professors, as those who are in a position to design and those who are in a position to bring about that kind of a change for the upcoming students, for the next generation, that we work together. The academia, the industry, the governments, the expertise that is available across each of these various domains. So we need to be able to collaborate, to think ahead and see how best we can bring about that kind of a change. So today the students are very smart. They are able to pick up a lot of things because of the large number of resources that are available. But what could be better that we all collaborate and see that we provide some kind of a platform more specifically to the girl students, because there is definitely a change. It has been observed. There are a lot of studies that say that tell that the decisions taken by suitable representation of women in any organization, there are a lot of wonderful results. So whether it is the finance minister to the normal banking to any other industry, you see the top to all the other layers of the industry of education, you do find women making significant contribution. So I hope that there would be a good collaboration amongst all, I mean, experts from the industry, the academia, and all the other influencers. Like what was pointed out in the video that we just saw. It's not possible that kind of a vision of including more and more women would be possible by just few hands or just few thought leaders. So with a lot of students being exposed to real-time hands-on sessions and looking at collaborative work, taking up major projects, then that will be helpful in reaching our vision of including women who can make a significant difference to each industry where they are given an opportunity. So that is it from my side.
Thank you so much, Dr. Sudha. It was a very insightful talk, and you're really a true inspiration to many. Thank you so much for making it on a Saturday morning. Thank you so much.
My pleasure. Thank you.
Now, moving on, after this inspirational keynote, we have Vidya Chandrasekharan. She's a product and data leader at PayPal, who would be presenting a tech talk. Vidya has got a rich, a strong 17 years of data experience, starting as a database engineer. And apart from her work, she's passionate about life learning and mentoring youth, particularly in data science. WiDS Hyderabad, welcome you, Vidya, and over to you.
Thank you, Salakshana. Thank you, everyone, for joining this meeting on your weekend and giving me a precious 30 minutes today. And thank you so much, Salakshana, and the other WiDS organizing team to having given me this opportunity. It's an honor to be speaking in the midst of you all. Let me introduce before I go to the topic I'm going to be talking about. It's called as model governance. But before that, a small introduction. Salakshana pretty much covered that. But I want to kind of give you a small description as well. So I'm Vidya Chandrasekharan. I manage the product and the data science for merchant-facing products in PayPal. I'm a senior manager for machine learning here. And like Salakshana said, I'm very passionate about mentoring young talents, young women talents especially. And the topic is going to be about model governance. Sorry, Salakshana, I'm not able to share the deck for some reason.
Have you, is the share option active?
No, it's not active. Only meeting organizers and presenters can share is what I can see here.
Yeah, just a bit.
Yeah, you're a presenter, madam. You're a presenter.
Okay, but it's still not visible for me to, that's still disabled for me, that option.
Yeah, Vidya, 1 second.
Take your time.
1 second, madam. 1 second.
1 second. It is women conference.
I have joined from the browser. I hope that is not.
Yeah, no problem, no problem.
Yeah, Vidya, you're a president.
I'm able to see that now. Thank you. So this is the topic that I'm going to be talking about the next 20 to 25 minutes, model governance. I'll give you a little bit description about what model governance is in the next few slides. But before jumping onto the topic, I want to introduce on what PayPal is, because that's the company that I come from. I want to give a couple of introduction about PayPal and what we do for data science in PayPal before moving to the topic. PayPal, as you all know, many of you would already know as a world leader in digital payment industry. And we not only provide, it's not only the checkout button that you see in the merchant or a click to pay button that you see in the website, but it's much more than that. We provide a lot of other services and products to customers and merchants, starting from cart reduction and program for the merchants, loyalty program, or credit products, invoicing, etc. And these products are given, like this is our overall umbrella under PayPal. Braintree, Zettle, Honey are all merchant-centric products. Zoom, Venmo, Swift are all consumer-centric products. And we have about, this is the scale with which PayPal operates. We have about 426 million active accounts and 5.3 billion payment transactions. The stats are from Q4 2021. So this will give you an understanding of the scale with which we are operating. In terms of data science and machine learning, we've been doing that for quite a long time right now, more than a decade, and applying data science in various domains like fraud prevention, risk management, credit services, customer service, acquisition of customers, etc. And the reason that we are able to do that at scale is because, as you saw in the couple of slides back, the data that we have is the stats that you saw kind of gives you an understanding of the amount of data that we might be having. We have about several petabytes of data in our databases across transactions, customer behavioral data, and customer demography data, and data that we also buy from outside, which is called as third-party data. With all of these very rich data points, we are able to scale the machine learning solutions to several million transactions or several million data points. Not only the data, the other things that would help us in terms of having an efficient solutions, or the infrastructure that's a high scale infrastructure that is able to compute both for real time and batch models, and the processes and governance that we have kind of it's an art over a period of several years that we have got understood the art of managing, not only creating the data science solution, but also managing them at the same performance. So that's pretty much what I had to kind of present on the PayPal ecosystem. Moving on to the actual topic today, the topic is model governance, like I told you. Why do we need model governance today? Why is it a need for model governance? First of all, what is model governance? So you can see some of the statistics that I have here from Gartner, McKinsey, and Forbes. There is is AI or machine learning growing as an ecosystem is beyond debate these days. We know that it's definitely there in all spectrum of our life. Some of the stats here says like 5% of EBIT, 27% of enterprise customers say that 5% of EBIT is earnings before interest and tax, right? That comes from AI products. And 56% of enterprise customers say that they have an adoption of AI in at least one of the function. And the forecasted revenue for the next 1 year, 2022, is going to be 62.5 billion. So you can understand from the data, from the stats on how big the industry is growing. And with that, we are also able to kind of, you like it or not, you're aware of machine learning or not, you are still using, you're consuming the decisions, automated decisions from the algorithm in your daily life. You're shopping, the pattern that you shop, the products that you buy, the posts that you read, the friends that you like and share, the news articles that you read and share, the movies you watch, the credit amount or a limit that is given to you. All of that is based on the algorithm decisions these days. So it's no more 10 years back. I started machine learning 7 or 6 years back. The questions were mostly around, can we do this? Can we do a small POC? Is it possible? These are the types of questions that were spoken like few years back. Now it's completely changed. The types of questions that is spoken these days are, can we scale this to trillion data points? Can we bring the latency from 200 milliseconds to 100 milliseconds? Can we do this in an edge device? So these are the matured conversations that we are having today. So software engineering has been around for several years, and we know the art of having a process around to ensure good quality. And if at all the quality goes down or the system breaks in production, we know how to restart that and how to get back to the normal self. So, but with the advancement of AI, do we have the same level of maturity in machine learning? That's quite debatable. While the growth of AI is not debatable at all, the art or the process of having a governance is something that's still not in a it's not so matured in our ecosystem is what the reality is, right? So that's where the governance comes into place. So governance, if you have to ask me what governance is, governance could be the quality frameworks or quality controls or checklists or the measures or tools or automation processes that you have. You can call anything under whatever word that you call governance. It is a process that makes sure it is not just we are providing best machine learning solutions, but we are also managing that at the same level. And if something goes way to go wrong, we are able to correct it quickly. So that's what governance is all about. Why do we need governance is some of these things that you read on a daily article, right? There is, there is a lot of adoption in the industry, there are still some doubts and trust issues in accepting that as it is, right? Because of all of these news that you probably might be seeing in the news as well. In a recent fallout with a company called as Zillow. Zillow is a housing, that they are into the housing market. And one of the division that they operate in had an algorithm that bought the houses from the market at a rate that was predicted by the algorithm. And after
I request all the participants to mute yourself, please.
Yeah, it would be great if you can mute yourself if you're not speaking. Thank you. So Zillow, let me go back to what I was talking about Zillow. So Zillow was a business, they were into the housing business. So they had a business unit that bought the houses from the market at a rate predicted by the algorithm. After doing maintenance or renovation of the property, they sold it back to the market at a rate predicted by the algorithm. But recently in Q4 2021, Zillow had come out with that they had lost about 881 million because of this prediction algorithm, right? The reason is it had a 5% of margin of error. This 5%, when you extrapolate to the millions of dollars, and the algorithm, they realized that algorithm had made an error both ways. While buying the property, it had bought it at a rate much more than the going rate in that particular locality. And after renovation, when it's selling back, it sold at a rate much lower than the going rate in that locality. So it had actually bled money both ways, right? This is one typical example on the loss that one business can incur if they do not have enough process. And coming back to another example here, there was recently, this was a very researched article that you can find it in the website as well. So there was a research that was done to see, can we replace the human judgment or human decision and replace it with an automated machine learning for deciding whom should we give parole to. So in the US, while giving parole, usually the judges used to go back to the history data, look at how the convicts are, or the accused are in terms of their behavior, and then grant if they grant the parole if they are eligible. So when they replaced that with algorithm, stark distinction came into picture, right? A big bias came into everyone's visibility, that white man was always rated low risk than a black woman, especially in the cases where the white man actually did a lot of repeat offense and the black women did not do anything, had a pretty much a pure history in terms of that. It was very, very surprising. And that's when people started to realize that the data that we have historically might have bias. And if you're just using the data as it is, then we are just going to pump back that bias to the community at much, much larger scale. A judge would take like 2 to 3 decisions per day, but give that to the algorithm, it can take 300 to 500 decisions, or even to several thousand decisions per day, right? So it's a very dangerous trend that people started to uncover, and they have started to kind of put all of the process and regulations in place. So broadly speaking, these are all the risks that we very, very similar to software engineering. Software engineering also, you have a lot of risks that we associated with. We have a lot of controls and measures to control the risk. Similarly, in the model also, you have a lot of regulatory risk, right? Depending upon which area, which region that you are deploying your model, it could be governed by some of the regulations in that region. For example, if you consider EU region, you have something called a GDPR regulation, privacy laws that will not allow you to use any data points from the customer that they have not given a explicit consent on. You can't build you can't build a model based on the data that they have not given consent on. So those are some regulations we need to keep in mind. Quality of the data, is it like when you go to production, the quality is X, and when after like 10 days it is X minus 5? Should not be the case. How do we make sure the quality remains intact? Brand reputation, it's just not the regulatory and other stuff that we need to work. No CEO would like to see their picture to be in the front page of the newspaper for a wrong reason, right? So there are a lot of things that could go wrong with that needs to be controlled in terms of the brand reputation. Security, if you consider a health app, let's assume that the health app collects data mostly from men, and there is only a small representation of women, and absolutely no representation of women during their pregnancy or menopause, then what kind of safety it can give to people who are using the app, especially women who are pregnant? If they're using that app, what kind of recommendation would it give, and what kind of a security threat it could pose for that customer? So these are some things that we need to keep in mind. Cost, definitely, that's one of the what is it that I'm getting back by deploying this model, and how much does it should I have to pay to manage that? That's a question that we need to ask as well, right? So going back to quickly on what a model life cycle will look like. This is a fairy tale model life cycle. I mean, this life cycle is very much not true in actual life. If you could see a lot of zigzag and back and forth in actual production model life cycle, but this is generally to give an assumption of what kind of processes and what kind of checks that needs to go in each of the model life cycle. I'll work on the certain parts like requirements, data, and post-production, especially in this particular session. So before even we start this model, there's a lot of, I think, hype on building a model. Most of the online courses and most of the university syllabus focuses on just on the model building part of it. But there are a lot of things that could probably much more important, and model building itself only takes 10 to 15%. Lot of other activities that goes before and after the model building, right? That's the place where we need to have the checks in place. Like I told in the previous slide, if there is a regulatory compliance that governs a certain region, we need to make sure we ask the right question right before we started. Like, what are the type of data can I use for this model? Should I, do I have a liability to do an auditing after the model goes live? And what of legal regulations and compliance that I need to take care of? Because these questions is what will drive the development of the model itself. And again, how do I measure? How do I measure a model? Once it goes to production, there should not be a question that is asked like too late after the model is ready for production or after it goes, right? We need to ask right here, right on the onset, so that we prepare for the development phase. What do you call as a success of the model? Let's say that there is a propensity model for marketing that we deploy. How do we say that the model is successful? Is it success?
Sorry for this to be, madam. Do you have any PPT or you're only talking?
I am sharing the PPT or not. Are you not able to see that?
We are not able to see any PPT now.
Oh my God. Okay. Have I not been? Okay. Can you share, Sulakshana? I had shared that deck with you. For some reason, I'm sharing, but still.
Vidya, same here actually. Can you stop sharing and reshare?
Yeah, I'll try to do that. 1 second.
Yeah. Since you've already covered few slides, but it would be great if you could quickly take us through all the slides and conclude.
Sure. Are you able to see my screen now?
No.
No, I'm trying to.
No, ma'am. It's a beside the mic. There is a up arrow, madam. Just
No, I'm doing that. I'm doing that share.
I'm sorry.
I did that right now. Again, let me try a single window and see if that works. Is it visible now?
No, ma'am.
I don't know if there is any permission issue with the Chrome. I'll try and fix that. But Sulakshana, can you try to pop the deck if that's possible? I've shared you yesterday, right?
Yeah, so we tried it, Vidya. We were not able to.
Okay, that's interesting. 1 second, just give me 1 second.
Yeah.
Yeah, ma'am. Go to presentation mode now. Slideshow.
Vidya, we can see it now.
Jimmy, your mic is muted, but we are able to see your PPT, ma'am.
Vidya, we're not able to hear you.
Just give me 1 second. Since it's in a different tab, I'm having difficulties in going back and unmuting myself. Let me now unmute it and go back there. Let me know if you are able to see that.
Yes.
Okay, at last. Really sorry that I didn't notice this slide was not visible. So
Yeah, because I thought I would close the talk and then present something. So we were under that impression. But no issues.
Oh, sorry about that. So I was talking about, I think I went 4 to 5 slides. Let me go over. These are the slides that I presented on PayPal, the types of services that we give to the merchants and consumers, the scale with which we are operating in PayPal. And these are some of the areas that we are providing machine learning solutions to the customers in PayPal. And this is why we are having an efficient process in PayPal for machine learning. These are the slides that I covered. And in terms of the growth of AI, these are some of the slides, right? Some of the stats that I told. 5% of EBIT comes from AI solution. At least 27% of the customers have kind of confirmed that 5% of EBITs come from AI solutions. 56% of customers also confirm that they have an adoption in at least one field, right? And this is the forecasted revenue, 62.5% in 2022. Such is the scale of growth in AI. And these are all the decisions that we are automated decisions that we consume on a day-to-day basis. We are aware of it or not aware of it. This is how it works these days, right? And in terms of these are the examples that I told you just before I went off. This is the Zillow news that came out. They lost about 881 million in the forecasted the revenue that they kind of confirmed in Q4 2021. They confirmed that they had lost 881 million. Apart from that, these are all the examples. This are examples of the bias that we could have in a especially when it comes to judicial system. It's very, very dangerous, right? Because we are kind of discriminating people based on their race or age or gender, and that's the bias that has been in history. We are just taking that and extrapolating in a much larger scale. Any questions till now? I think I covered until this before I went off. Selection, I think I can cover from here, right?
Yeah, Vidya, please go on.
Yeah, okay. So this is the model life cycle I told you about. The requirement to deployment, there are multiple things that could go wrong and some of the checks that we need to have. I started with the requirement phase. What are the questions that we need to ask? What are the checklists that we need to have? A process. So it should not be a haphazard way of understanding what is needed as we go through the requirement phase or as we go through the development phase. There should be a very well-defined process or checklist that we ask the right questions at the right place. The first due diligence or process that is very important in the development phase can be data, right? The time that we spend in data at this phase can reduce the time that we are spending elsewhere, especially the time that we spend post-production will be very much reduced if you are very careful here and we spend enough time on the data side. For example, what I mean by data, examples of the bias I showed you in the previous slide. So careful sampling strategies, we call that strata, right? For what kind of a strata that we are having in the model, in the training data is going to determine, are we going to have any bias? Are we going to have instability once the model goes live? So in case, example, in case you are having a product recommendation engine that you're rolling out, so the due diligence, for example, would be, are we having enough data for all of the products? Let's say there could be a product which is like there for a decade, and you would have several million records for that. But a product rollout that happened only 3 months back, 4 months back, will not have so much of representation. By having combining both of them in the same data, we'll be very biased to the data, the product that's been there for a very long time. Though the product that was recently launched is much more stronger product or which will bring more revenue to the business. So those are some things, or the bias, right? If you are rolling out the credit eligibility model, then do we have representation for all the minority groups? Do we have from the every gender, race, There could be some regulations like equal opportunity, credit opportunity. So all of these regulations also will taken care if we have enough strategies in the data side. And many company also buy additionally data from outside. Those are called as third party data. And in case we are relying heavily on the third party data, we need to have enough vetting process or due diligence to ensure the data that we are producing from our own organization and the data that we are buying from outside are of the same standard. You could do every due diligence to make sure there's no bias in the data that we are using. But if the data that we are buying from outside is a mix of this bias, then at the end of the day, it is going to beat the purpose. So it will defeat the purpose if we are not kind of keen on making sure that we are concentrating on the processes that needs to be put in here. The quality of a data could also, not only the quality of a data in terms of the pipeline that we have, but also the data that we are using it during the training. Is it available during the inferencing is one question that we need to ask. Like for example, if you're using state of the customer during our model training, because we have a historical data, can we be sure that the state field will be available during your production, during your inferencing? If there is a new customer who is signing up, if the state field is an optional one, then how are we going to make sure this field is available during inferencing? So in that case, even though your model performed very well during the training and testing, it is not going to perform at all once it goes to production. So these are some valid questions that we can ask on the data. Second important one during the development phase could be explainer, right? So why do we need an explainer? First of all, what is an explainer? So as you all know, with the advent of the cloud technologies, the data that is available in terabyte and petabyte these days, deep learning gives a very good performance. With very little work, you can get a very good performance in a short period of time. So there is a lot of adoption in going towards the deep learning technologies when compared to traditional statistical logistic regression or linear regression, right? But at the same time, what we are losing there is logistic regression or statistical models usually give us a good explanation on why the predictions are done that way. So if your credit is declined for a certain customer, we can go back to the model configuration. Oh, this credit is declined because 5 times there has been non-payment in the last 5 months, and their salary is low or something like that. We'll be able to explain very easily. And think about the case of deep learning. Deep learning is a mix of several layers and nodes. And the way that deep learning learns is by forward propagation and backward propagation. By doing a partial differentiation, it is able to arrive at a good weight for each of the features, right? So let's assume that you have to explain this model to a layman, even to a experienced data scientist. Understanding why the model performed the way it performs is a very, very difficult question to answer, because we don't know. Most of the times it's black box technology, right? I don't know. I have the best data and I selected the best deep learning algorithm, so I have the best result is something that we cannot say these days. We have to give fair enough justification why it is behaving that way, right? So explainer is becoming more and more important to develop or keep in mind during a development phase. It can be done in multiple phases. Either you can choose to still go with deep learning algorithm, but build a surrogate model in parallel. Let's say you're going with something like a multi-layer deep neural network for your production model, but you also build a very simple logistic regression in parallel, so that you can use the deep learning model for prediction for the users and explain the logistic regression to your auditors. So that's one thing. There are multiple ways of doing that. There are a lot of options available these days. When we started, I think we did not have a lot of options. Now we have Shapely values, Lime, and other solutions H2O provides, etc., that we can make use of. Why do we need explanation? Is multiple things, right? Even for a data scientist who deploying that, they need to understand why is my model behaving this way? Is it because the data is like that? Because the hyperparameters are done like this? Why is my model behaving like that? Is something even for us we need to understand. That will help us to fine tune the model or identify a bug and fix it. And additionally, this model is not going to be used by the data scientist. You have to deploy it somewhere. a business team or some other stakeholders that's going to consume your model results, right? So they need to be trusting. They need to trust your model results. The way that they can trust your model results is show the explanation. See, this is the way my model is working. These are the variables that is important. And lastly, legal and auditing requirements become much simpler if you have an explanation in place, right? Otherwise, it's explaining to the auditors is something that you don't want to be scrambling at the end of the model life cycle. And you can do the explanations in two ways. Global explanations will give us an understanding of features, their importance at an overall model level. But local interpretations will give us at an individual customer level. Like while the global is helpful at a very high level to understand the model, auditors might be very inclined towards looking at the local interpretation. For example, why did you decline the credit for this customer? If I can explain that with the right explanation, then there should not be any problem. So moving on, the very next important thing, version control. In the development cycle, when you're ready for production, you deploy that. But software engineering, definitely version control is something that we've kind of been doing for a very long time. We always have a Git or some other version control. We deploy our code there. We branch out, commit only the, they take it to production only the committed code. But considering ML systems, the version control is not that simple. It is much complex, because in a software engineering, version control or the whole application is just the code, right? But in machine learning, the code is just one of the part of the system. The other parts could be data. Without the data, there is no, the code is not going to be relevant. The model configuration is not going to be relevant. At the end of the day, model configuration is the one that goes to production. You're not deploying your data, you're not deploying your model code, you're not deploying your hyperparameters. You're only deploying your model configuration. So easily we will forget all the three parts of it. And the next time when something breaks, only then we'll be going about and saying, oh, what is the data that I trained my model on? You will not find that anywhere if you don't have a version control, right? So understanding these and putting a version control process in place is very important, because it's like having a locking something and throwing away the key. Unless you have a data that you trained on, you don't know what is going wrong, what is the next version that will be right, what is the bug, and what kind of hyperparameters that were used in the model configuration is nothing. So definitely a good process and review needs to happen at a version control level. The next important thing is after going to production. So far what we covered were questions and checklists before I start the project, during the project, when I'm developing it. Now is the very important part. What happens after I go to production? How do I manage the production's machine learning performance? So let's say that you're deploying a model that is performing very well in terms of precision, recall, RMSE, any kind of metric that you develop your model based on, right? So based on that, if you once you deploy, it's not going to stay the same, because it's not a software that you deploy and it's going to behave the same way. The data keeps changing every day in out, and based on the data is what your model will behave, right? So very easily, like the Zillow example I told you, 6 months down the line, 9 months down the line, we should not wake up and understand, oh, the model has been not performing well, we have lost quite a lot of money, or we have lost quite a lot of customers. That should not be something that you wake up and find one fine day. The model has to be monitored on every single day for the changes that's happening based on the data, based on the variable, on different other software that you're deploying dependent on this, right? So the way that we can measure that is twofold. One is if you have a model ready and it has like 10 to 15 variables, that is key variable, just keep monitoring how the variable is performing over a period of time. Let's assume the transaction value is one of the variable that you're deploying, right? That's a key value. So let's say average transaction value is $600 today, and 6 months down the line, it can be $1,200. So that's a big variation, but over a period of time, maybe it's not that drastic, right? It would have changed $10 per day, or over a period of time, it would have averaged out. So we need to understand, is there a shift or a drift that is happening over a period of time? That tells us one other story also. Maybe the data is changing. Maybe the COVID lockdown is ending and people are, their buying habits is changing, right? So the data, the model that we deployed is based on COVID lockdown behavior. So since the model variables are drifting, is it a time for me to retrain the model? Because it's not going to behave the same way with new data, right? So that tells us like if there is something wrong with the data that is coming in, maybe there is an UI change that happened, that is there is a bug in the UI that brings the data wrong, or it could be that really the pattern is changing and we need to retrain the model all over again. Similarly, on the model drift, right, the performance of the model, let's say today the model is it is evaluated against the number of customers that they bring in, right? So let's say, let's assume that we are monitoring over a period of time, and if you see the number of customers through the model is coming down very much drastically, then either there is, again, like I told you in the previous example, there is a big bug that is there in the software that we need to correct. That has nothing to do with the ML system, but there is something on the source that bring the data to the ML system, or generally the trend is changing and we need to retrain the data. So these are some checks that we have definitely keep in mind once we go to production. These are just some samples of trends and analysis that we can keep an eye on over a period of time, right? I'm not going to spend some time on these slides, but this is just to give you some kind of an understanding. And again, very important one. So this is again like the example I said, you lock something and throw the key. That should not be the case here. Once you're going and deploying a machine learning model, we need to have enough backup plan in case the model today I'm deploying and tomorrow there are multiple customers complaining that they are not able to get to that application form. They are getting rejection in all of the application forms. Then we should not be just starting our journey of understanding what to do at that point of time. We should have a well analyzed process to make sure what are the things I have to back out in case something is wrong. I should have enough checklists, like for like an example like this, the variables have to roll back to what it was before, models have to go back to the previous version or previous rules that it was using, the rules that I apply on top of the model has to be put back, the experiments that I set up in place, those also have to roll back. Having a rollback plan should be one of the things that needs to be checked out or reviewed and signed off before the production, before the actual production deployment. And then again, the last couple of slides is going to be just auditing models. Like the Zillow example, we should not be identifying during the audits of the year-end quarterly review that the model is not performing right very well. So the performance of the quality, sensitivity, latency, all of that should be audited on a regular basis. It can be on a weekly basis, or you can have your own checklist of tests that you're doing, but that has to be executed on a periodic basis. That gives an understanding that you have a fair control on the models as it goes live. Last but not the least, feedback from the customers wherever is possible. Like if you have a recommendation that you're providing to the customers, you can also give some kind of buttons that could get the feedbacks and recommendations from the customers in order to whether you need to fine tune the model. Yes, Sulakshana?
Yeah, Vidya?
Can you hear me?
Yes, yes.
I'm almost done. Only one more slide to cover. I'll just go on and finish that.
Yeah, please go on.
Sorry, I lost that track there. So, and last but not the least, very related to the session we are having, building a diverse data science team is very important. If you don't have a diverse team, what happens is we will not get a new perspective on data. We will not get there will not be any checks and balances there. So today the data science or machine learning is like dominated heavily by Asian male. So consider this as a trend that is going to happen. What would happen is over a period of time, you will see a lot of decision that is made from these machine learning models is towards what an average Asian male would think, right? We don't want our future generation to be kind of exploited by the machine learning automation. So building a diverse team is also very paramount to building a good process in place. That's pretty much what I had. And once again, thanks for giving your time to me today. Thank you, Sulakshana. Over to you.
Thank you so much, Vidya. That's a lot of outstanding work in the field of data science, and this is what we call a real work. Really appreciate whatever you've contributed. And thank you for making it for WIDS Hyderabad on Saturday morning. Thank you so much. Moving
Thank
on.
you, and sorry for all the glitches, Sulakshana, unexpected glitches. Thanks for everyone sitting through that. Thanks a lot.
That's completely all right. Thank you.
Thank you. Bye.
All right, now after the technical talk and the keynote, we have a special video message from Maithili Rajavelu, who is a data science leader, influential data science leader, I would call her. And I would like to play that message for you all. It's all about her journey, the ups and downs, and her struggle and her achievements after all the hard work. Can anybody confirm if the video is visible?
No, ma'am.
All right.
You have stopped your screen sharing.
Town called Gudiyatam at
Yeah.
Velu. I did my small. Hello everyone, this is Maithili. I'm a data science leader. I'm here to share my personal journey with you all to inspire. I was born in a small town called Gudiyatam at Velu. I did my schooling there and polytechnic in triple E course and moved to Coimbatore to do my engineering. During my school days, I was dreaming to become a cardiologist to save life and do more there in the medical field. Post 10th grade, I was not getting a college which I would like to take up a course in 11th and 12th grade. I've shifted my dream from doctor to engineer. Then I did my polytechnic in Rajagopal Polytechnic, Kudiyatam during my last year, and that's when government brought a change that diploma folks can join directly to second year in engineering. And I was lucky enough to get into Coimbatore PSG Tech into a computer science course. And I was placed from there to directly into TCS, and the day one job was to solve Y2K problem. That's where I was trained to identify problems and automate wherever possible and bring change through automation. Post that, I was placed into data warehousing, and that's where my journey began in data space. For last 22 years, I've been in data, almost worked 9 years of the data management and analytical domain space. So during those days, we had a very limited technologies to perform data warehousing. And of course, we have a umpty number of technologies today to solve. And those days, it is very limited. We had Oracle, SQL, Teradata was not even there. And my mainframe was just moving from black screen to the white screen through UDB, which they call it as Universal Database. That's where we tried to implement data warehousing for insurance company. The data warehousing requirements were very simple. Bring the source information and do some transformation, clean the data, do some transformation, store it, and deliver it. Post that, gradually we need to build a data mart for claims and premium business to use this for reporting purpose. It may look very simple at this point in time, but those days, collecting the source information, understanding the source detail, and connecting that dots with whatever the information with which business is looking out for was not that easy. And we were doing almost, it was like 8-member team. We were together and we were doing our own architecture and implementing it. You can easily imagine the failures which we would have made, because all of them are just 2 years, 3 years, 4 years experienced in the IT. And we were just came out of college and with the basic knowledges on the SQLs, and data space is completely new to understand because all of them were working on application development using Java, because Java was really huge, a huge hit, and .com period, you can imagine that, those period. So we were playing with the data, miserably failed, and any reports which they were asking in 24 hours window, we were not able to deliver it. Even whatever the job which we have developed it, when we submitted, it was running for almost 2 weeks, 3 weeks time together. It was real fun, I would say. There were days where we were in the office. Those period, I think I was in US, and even the US 2021 to 2023 is the period where I was there for an insurance client, and I still remember I went to office on Thursday morning and returned back home only on Monday, fixing a small job or a small query which is supposed to be productionalized in a month's time. It's running without getting out of it. It's a huge failure. Then we assembled and we have changed that architecture completely. The way we have implemented everything, that has been changed. And that's when I have realized, think differently. Always going in one direction will always block you and not thinking about the other options. Since then, think out of the box. If something which you are failing, if you see that some failures, don't get stuck up there. Come out of that space and look from the broader perspective and try to solve the problem, and you will definitely achieve. And then post that, almost 7 years of my career into my journey, I was asked to go to a US client for 3 months for a reporting requirement, wherein they were asking me to develop some of the script for reporting their campaign management group. That's where I have identified a huge business opportunity, the way they have actually they were actually sourcing the data, the way they are actually transforming the missing pieces and all of that, I was able to see that because I have miserably failed. You can easily imagine the way we would have done multiple architectural changes to implement it. I have got a very good experience. And now after seeing this, I was able to easily connect the dots, and I have proposed this stating that these are all the areas which we have, and these are all the business problems it can solve by bringing changes into that. And client really liked it. Guess what? I went there only for 3 months and we got a project. I grew up the team from 1 member to 125 member team for almost about 5 years. Huge success, and it was one of the greater time in my career where I have learned a lot: client management, business management, program management, and data management. Lot of stuff which I have learned it, and brought so many automations, tool development, so many things which I was able to do it. I was actually given a free hand to do whatever I wanted to do it. And then that's when the Hadoop thing came into field, when people started talking about it. You guys data will not understand this, which is completely Java based. You guys are working only on the RDBMS mindset will not have this distribution functionality. Obviously that triggered, why can't I? Let me take a chance. Then I had a mentor who actually helped me to explore few topics and helped me to understand the problem statements and approach it in a completely different way. Remember, in every person's life, in a career or a personal life, it is always better to have a mentor, a coach, because it's not that all the problem can be solved by you. And of course, I've been having this journey. I was lucky enough to have a good mentors all through this my career, who always helped me to shift my thought, my ideas, my career into a different path. And right now I'm into data science space, where I started as a developer, automation engineer, to the place what I am in, which is completely a huge shift from my career. So then after that, I brought the data warehousing into Hadoop, dumped it, and tried to solve the business problems on data through Hadoop. Not the entire data warehouse can be replaced into Hadoop, and I started very thin and gradually taken it to the larger extent. And now we are actually into the era. Gartner is currently saying that Hadoop is dying and the legacy platform modernization is going to be the next focus area for next 5 years. That's the way forward what we are currently doing it. Coming back to the life journey which I had, be ready for any changes which is coming on your way. Be patient. Don't expect the results immediately when that something comes on your way. You will not be getting it. And be bold. Anything that comes, don't give up. Things may not happen as you think. Be bold. Be confident that you will be able to do it. And being a woman, which is very much important because I see the pattern. Women are always be thinking that, okay, let me take and compromise. I will be the person to always raise my hand stating that, okay, I will take care of the family and then I will compromise my dream. I will be saying no for everything. And I will say that my job is to take care of family, kids, and elders at home. I'm not saying that don't take care of it. Even I do have in-laws and I'm taking care of them. I do have a kid and of course have traveled along with this journey and I have never taken a break in my career. And of course, without compromising my personal side and my career side, I traveled up until here in the space and doing great. So one thing for you all to remember, world is full of opportunities. Look out, take that opportunity as it comes and get succeed in your dream. Don't give up. All the best.
All right. Yeah. That was a very inspirational message from Maithili. I would also like to add on. She studied in a Tamil medium until 10th in a government school, and her classroom was under the tree. And she used to walk barefoot to the school. I really respect her and admire her, and I really appreciate whatever she's doing now. Now, moving on to the next Tech Talk, we have Preeti Chauhan, who is a BTech graduate and an associate director of data science in Novartis, and she has been she has got 15 plus years of experience in the field and worked in different organizations, most eminent organizations like IBM, Wipro, Cognizant, and Novartis now. We at WiDS Hyderabad, Preeti, welcome you and over to you. Preeti, we're not able to hear you.
Your mic is muted, Preeti ma'am.
I'm so sorry. Thank you so much, Sulakshana and the entire WiDS team for giving me the opportunity to speak here with and sharing the platform with such wonderful women in tech. Can you guys hear me now? Because I can see, yeah,
yes,
Sulakshana, your video got stuck, so I thought.
Yeah, yes, we do.
Okay. So as Sulakshana said, my name is Preeti Chauhan. I have around 15 years of experience in data and AI, currently working as a director in AI molecular lab, overlooking the delivery of AI products end to end. So today I'm going to talk about something that I am personally very excited about. It seems like a new trend, though it's not. It's called knowledge graph. So let me share my screen with you guys. I hope I'll be able to. Give me a sec. Can you guys see my screen?
Yes, we can, Preeti.
Okay, let me put it to. Yeah. So as I already mentioned, knowledge graph is one of my favorite topics. It's exciting area, and as I call it, the fabric for the integrated knowledge retrieval. Now let me ask you, like the companies that you see on screen, Amazon, Airbnb, Lyft, eBay, Walmart, Facebook, NASA, what do they have in common? Yes, the answer is simple. They all use knowledge graph to understand their market, customer, and future. And different people in the companies around the world have a lot to say about, a lot of positive things to say about knowledge graph. For some, the productivity has increased many folds after using the knowledge graph. Some says the time to insight had decreased. Some says they were able to find new patterns in their data which have never been there before, which they haven't seen before, right? So just don't take my word. You can Google it out. You'll see a lot of success story with different people and company using knowledge graph. Now, speaking of Google, who else uses knowledge graph? See, here is a screen where you can see an evolution of Google search prior to it's a screen from prior to 2012 and post 2012. I'll tell you why I mark 2012 as an important landmark here. So prior to 2012, there is a screen. I'm sorry for the bad quality. It's one of the archive pictures that I could manage to get from Google. So you can see on the left hand side, the Google search is from early 2000s, right? So it's mostly the linked documents on web or the linked web pages, right? So you can see, I search for, say, somebody search for Sarah Palin. You can see a lot of different articles as a search result. While on the right hand side, what you see here is there's a visible difference, right? So what is the visible difference here? Just a sec. Yeah. So the visible difference is basically the knowledge panel and the info box that Google has introduced, which make like everybody's life easier, especially the researchers, right? Or the people who want to get insights or quick insights out of search results. So what happened in 2012? Yes, Google introduced Google Knowledge Graph. So now the data storage, the data, how they store data is changed. The data is no more the linked web pages, but it's also the linked data or the linked entity or the linked facts, right? Which can be presented, which can be collected, linked, joined in any way and presented in a certain way that is useful to the end user. And it enhance the user experience many folds, like everybody would agree with me, from the left hand side to right hand side. So actually the knowledge graph played, and Google was an early adapter, by the way. So it played a very important role, knowledge graph, to enhance their user or customer experience. Now, this is one of the, thanks to Google, I can track down the article published in 2012 about the shift, right? So what did it say? They introduced the Google's knowledge graph, and then they said, what is the gist of it? By using the knowledge graph, what you do is to find the right thing. So no more wasted time tracking down the data. You reduce your time to insight. Now, since everybody these days are talking about knowledge graph, every other company is using the knowledge graph or trying to switch to knowledge graph. Is it something? Is it a new concept, right? Of course not. It's not at all a new concept. In fact, I mean, I know many of you might have studied computer science and studied a lot of data flow graphs, binary decision diagrams, state charts, and all. They all are in some form uses graph. In fact, as early as 2001, Sir Tim Berners-Lee, who is also the father of WWW, he proposed that web should not just be the interlinked documents, but also interlinked data. where he proposed the idea of knowledge graph. So it is as old as, early 2000s. But there's a current surge in, the popularity of knowledge graph. And why is that? It's mainly because of two reasons, right? One is organizing information over the internet, and the second one is data integration in the enterprises. Now let's see both in a little more detail. Now, when I say organizing information over the internet, why do we need knowledge graph? See, what happens in 1 minute of internet in 2000? What happened, right? So 3.8 million requests were sent to Google. 3.8 million requests, Google searches were made. 1 million login to Facebook. 4.5 million videos watched on YouTube. 2.1 million snaps taken on Snapchat, right? And there's some 50,000 new posts were posted on Instagram. There's many hours watched on Netflix and all. Now, this data, there's something special about this data, right? This data is not traditional data. It's not structured. It's unstructured data. It's as we speak, right? So we speak in words, language. This data is like that, right? Video, audio, a lot of unstructured data is there. How do we consume this data? How do we store this data? Now, storing this data might not be a problem with the big data, availability of big data and all, but how do we consume this data? How do we organize this data? How we connect the dots? How do we end up, saying this user on Instagram looks like this user on, say, YouTube, and they are watching, similar thing. Maybe I can recommend, something of his interest to retain the interest in the platform, something like that, right? How do we connect the dot, basically? This is where the graphs comes in handy, right? So, for internet, if I talk about internet, when you do the basic thing, when I generally log in, the first thing I do is Google search over something. This is the most frequent operation that I do. And what Google uses, it's apart from Google Knowledge Graph, it uses for collecting the data, scotching the data or information across the internet. It uses a lot of different other data sources. One of them is Wikidata. So Wikidata has trillions of facts and the data points stored with the relationships. So it is one of the largest free knowledge graph by Wikipedia. I can't, in fact, imagine most of the search is complete without it. The knowledge panel or the info panel that you see on the Google search is basically coming from a knowledge graph itself, where the different entities and entities like in forms of people, places, organization, facts, they're connected seamlessly, through different relationships. And when you click, so there are algorithms which decides like which nodes needs to be selected or which relationships you are looking for, and what you get is the best user experience or the best data that you are looking for, right? So this is why we need the graph for organizing the data over internet, because it's first thing, it's so huge, so unstructured, and we have to structure it, we have to link it basically to get the seamless insight out of it. Now, the second one is data integration in enterprises. Now, why do we need the graph for that? So I'll take an example, since I come from the pharma industry myself. I'll take an example from the same industry. So we make medicine for, sorry. So we make medicine for patients, right? And for us, it is very, very important to understand our patients, right? Who we are treating, what are their, say, unmet needs, or what are different segments of patients, or everything about patients, so that we can treat them better. Now, if I say for that, what I need the data on the patients. As I said earlier, there is no dearth of data anywhere. There's, huge data available. But out of that, how much is usable is that question. How can we use it? How can we say that this data of this patient is actually linked to this data in another set, right? So this is where the knowledge graph comes into picture. So for patient data, see, we have a lot of data sources. Like we have the patient forums where patient can go and talk about their diseases, about what's working, what not working, what drug is being taken, what drug is having side effects and all that, right? So a lot of information on those patient forums, all unstructured. Then again, we have data sources like primary market research data, where the companies like Novartis and the third-party companies go to the patient and do some market research and understand about whatever topic, say a drug uses or their side effect or the disease itself, right? So then there are HCP forums where HCPs are giving advices, say rating or talking about the talking about the drugs or disease, things like that. Then we have medical publications where people publish their studies or clinical trials are there. Then we have each EHR claims where you have patient history. You see what medicine has been given, when he has been hospitalized, when he has been released and all that, right? When relapse happened and all those things, the patient history. So again, there are a lot of data. Now, how do I harmonize this data, right? For example, and this is very, very, generic thing that happens in a pharma company. So I want to get in competitive insight for one of my competitor, right? I want to understand for me what is working for my drug, what is working and what is not working, and for say some competitor drug, what is working and what is not working. I can maybe if I work as a brand manager, for example, I want to understand that to run my next campaign. So it's a real life example I'll give you. So recently, what happened? So a brand team wanted to run their new campaign for a brand, and they wanted to understand for us what is not working, so that we can address it, and for say our competitor what is working and what is not working, so we can leverage it, right? But when we looked at the data, so for that, we have to look at the data for the drug uses or the patient data and all. What we had to do, we had to go to the different team, because there's a different PMR team, primary market research team. There is a different digital media team. There is a different team for clinical trials, right? They use the data. So we had to go to different team and ask them, these questions. They give us some information, insights. What we get out is the siloed insights, right? So we get some insight from PMR, we get some insight from HCP forum, publications, clinical trials, claims, EHR, real world data. And in the end, what we have different silos information that we are trying to, or the brand team is trying to put together to understand what can be leveraged, what cannot be, right? So instead, what we did, we took a brand and then we built a knowledge graph on top of all the data that we had, right? We entitized the data, we put the data together, connected them with different entities and relationships and all, and then we built the data and knowledge graph, clinical knowledge graph for a small one for that brand particularly, just a POC sort of, just to understand how it works, right? And then we try to dig some pattern out of it. Now, interestingly, we were able to find very, very niche kind of patterns in the data, which were earlier like considered maybe when we were looking at the standalone data, it was considered maybe a spike or maybe an anomaly, right? But when we put all the data together and have the holistic view of the data, right? Holistic view of any patient, and we can look at their journey through different angles or through different sites, then we understand, okay, there is a pattern, right? This is not working, maybe this medicine with this medicine, and all the data sets are actually in some ways proving that, right? I'm not liberty at sharing with you what the insight was, but it was a huge success, and then brand team was able to build the entire campaign on that particular insight that they got from an integrated knowledge graph. So again, that is why we need the data knowledge graphs in enterprises. There's a lot of data. I was just this was just the patient data, but then in any company you have a lot of, you have CRM data, you have people's data, employees data, you have customer data, maybe sales data, a lot of data you have, right? And there are some use cases which need a holistic view of the entire data sets, or maybe 2 or 3 different data sets put together. So that is why, that is the reason, again, I would say we would need the knowledge graph. The knowledge graph help us to bridge the silos and reduce the time to actionable insights. Okay, now I've talked a lot about knowledge graph and all. Now let's start with what is graph, right? What is graph anyway? So my favorite, the definition would be the mankind invented a system to cope with the fact that we are so intrinsically lousy at manipulating numbers. It's called graph. But a more formal one would be the graphs are general language for describing entities where the interaction or relationships. So yeah. So with the traditional, databases and all, the data is basically the isolated data points in some space. With the graph, it's not. It's basically a network of those data points which are connected or interacting with each other or connected with some kind of relationships, right? And there are actually many of the data sets which are naturally can be represented in graphs. For example, the event graphs, right? So you log into, say, your Amazon account. So you log in, you checked out one product, that's an event. Then you maybe added it to cart, that's another event. Maybe you went back and then liked one product, that's another event. The time you spent, you went back to another page, you browse through the catalog, that those all are events, right? So we are capturing the nothing but the user behavior in a graph. So this is the basic nature. The basic nature of these events are graphical in nature, where one moves to another. One event moves to another event, then another event moves to another event, maybe back to another event. So it's naturally it's a graph. The another would be the disease pathway, which is every pharma industry works with the disease pathways. Other could be the social network, everybody knows, like Facebook, LinkedIn, and all. They all are social network, and it's the basic example of a graph. Then you have internet or network of neurons. They are the natural graphs basically found. Then you have the molecules, right? Again, in the pharma industry, it's very important, to find new molecules maybe, or predict the molecule folding, all those kind of thing. So the molecules are nothing but they are the natural graphs basically, and there are a lot of use cases or experiments going on for the use cases, like I said molecule folding and all that, protein folding, where we use graphs a lot, because the nature of the graph, the basic nature of the graph matches the data itself, the data and the relationships itself, right? Another example could be scene graph. So any scene in a movie or any scene, a picture, can be described as a graph. It's called a scene graph. And there's a new application called identifying the objects maybe in the picture, or describing the picture itself, right? So where these scene graphs plays a very important part. Now, these were all different kind of graphs. There was some example, but then I believe that most of the data sets can be can be represented as entities and the relationships, and can have a potential to be built into a knowledge or added into the knowledge graph. Now see how knowledge graph works basically, right? So we have the data, right? If data is everywhere. Now, mostly the data is available as isolated data points here and there. When we add relationships to it, it becomes a graph, which gives us the dynamic context. But it's not the knowledge graph yet, right? When we add semantics to it, when we add context to it, then it becomes the knowledge graph, which gives us the deep dynamic context. Now, what does all that mean? Let's look at it with an example. So this is one of the data that we have, and obviously it's an unstructured data, and it is basically the hospital summary of a patient, right? So I've marked a few words for you so that we know we can use these words as our data points. Now, right hand side, what you see are the data points here, which are marked in the text, free text. These are the isolated data points. We cannot make anything out of it as such right now. The next thing we do is add the relationships, like the patient is linked to or examined through an MRI, or the patient has a history of facial weakness, or patient has a history of headache, or MRI of head was done, right? So these are all relationships we add to the data. We add relationships and it becomes a graph, but it's still not a knowledge graph. It doesn't have a semantics added to it. What we do next, it add the semantics.
Now, just quickly running through these virtual machine, like type of deployments when we have through virtual machines. So here, a web service which is running on the VM, it will be just serving a request, just as an HTTP request, and the output is given to the user on a maybe one-to-one basis. Then comes our containers, which definitely have an edge over VMs because they are resource efficient. They are also saving more compared to VMs for the business. So when we have good scope of machine learning model being inferred by the users, maybe this could be the second one which we could go about. And the third was the serverless, where we as data scientists do not want to worry about the infrastructure. Let the cloud provider worry about it, and be it Azure, be it AWS, Azure Functions or Lambda, they will take care of these needs. And be it synchronous or asynchronous operations, both will be taken care in the serverless as well as streaming deployments. So with streaming deployments, when a user places a request, there is a message broker, which is basically acting as a middleman. This is storing request and then distributing it to different processes. Now, it is basically not letting user know that there is going to be a one-to-one relation, because as requests come, it will store and then divert it to the model stream. And user has a feeling that he may feel that it's a one-to-one connection, but at the back end, this all is being taken care by a message broker. Then this is the final stage, which is the monitor phase, because if we think that we deployed the model, unlike in software engineering where we can relax unless a new requirement comes from the business or the users, things will be fine. Same is not the case with machine learning, because we constantly have to observe whether model is performing what it is supposed to do, meeting all the metrics that were basically given by the business. And in order to do that, we have a lot of tools into place to monitor drifts in the model. If a model which was performing well 6 months ago has started to decline or decay, if that sort of case happens, what are the next steps? How do we analyze that what is basically going wrong, and then govern the model, then understand basically the governance of the model, that model is able to meet the expectations, it is understandable to the business. So all these will be part of monitoring. A little intro about drift, which is basically a machine learning model's performance degradation. And as you see here, that on your left, there's a picture which says the model quality with time is starting to degrade. So as we deploy it, we put a threshold. Okay, if this is the threshold, the moment the performance of the model falls below this, we immediately have to replace it with the second model. Similarly, when this model starts performing well, we have to have the third model. So the 3 lines that you see here are coming from 3 different models that get deployed into the production, so that user do not get that bad experience and get stale results. These drift could be ideally of 3 types. There could be more type of drifts, because I've seen that many times a lot of research is coming on, and people come up with different terms, though they may mean the same at the back end, but I will be basically covering these 3 which we basically encounter. One is the data drift, which happens when the independent variables, which are basically used to derive that, yeah, this could be the dependent variables value, these variables properties start changing. So with COVID-19, we saw that people's behavior started changing when they were online purchasing. So models did not work well, and they had to replaced very easily. They had to replaced very soon, because the complete pattern was changed with no information about this type of pattern from history. Then comes the model drift, where a dependent variable property itself changes. So say maybe when we talk about an automotive system, we have warranty cases, and we know that a particular component, when it was failing, it was due to so and so reasons. But now, due to more number of components fitted into the vehicle, now these things are not affecting the model to degrade. There are new factors coming into picture which are actually affecting the model performance and resulting in the failure of a component. And the last is the upstream data changes. So say you have established a pipeline, a data ingestion pipeline. Data is coming from 4 sources, 3 sources, and immediately you see that one particular feature is it is not popular. It is coming nulls because you realize that the upstream team has probably changed that data, or they have removed that feature and replaced it with a new name. So there could be many things which could affect it. It could be a unit change. So all these will come into drift detection, and they will help us understand when a model's performance start degrading, because that is where again we have to replace our model with a new model. Analyzing the model in terms of basically is its transparency, model fairness, as already talked about by many other speakers as well, that models sometimes are biased towards white people in different scenarios. So all these things are to be analyzed by a specific team, and we should have an answer to business if we are going to tackle all these things with the model, because if any one of them rise up, our model could fail, and it may not be able to achieve what it is basically deemed to achieve in the project. So a little bit about the bias. Maybe as you see that we have divided our data into train, test, and validation. Before doing that part, we had created a sample. Okay, this data is going to be represented as the representative of the whole population. So if we think this model data is going into the model, it will fetch us the result. But we did not realize that this particular data was biased. It was biased towards a set of users or a particular vendor. And if we do not take that into account, model bias is definitely going to happen, because it is not going to be a representative of the entire population. Then comes the model transparency. Like as we know that business people are different from the data scientists, and in order to make them understand that when a model is performing, we cannot show them confusion matrix or accuracy charts, AOC, ROC graphs, because they do not make sense to him. They are not interested in learning all that. It is data scientist part, but they want to know why is it that these features are coming as most important in your algorithm. Make them understand. So we have to take care of these things before presenting to the business that why our model is transparent and not having any bias. Then comes a very important part, which is the model governance. After we have taken care of bias, we have taken care of transparency. Now, how do we take care of the local laws which are basically present in a particular region? It could be Europe, America. When it comes to Europe, it could be GDPR. So, taking all those local laws into a consideration, we have to make sure that model is actually complying to all those laws. And when presented to the business, they should not have any concerns when it comes to the laws. So basically, we can say that model governance, though do not have seen lot of importance in the initial phases, because machine learning was maturing in the initial part, but nowadays we have seen that a lot of attention is being given to model governance. if a model is being deployed, if it starts depleting, decaying, so taking care of all that part is also part of governance, that we ensuring that what is being deployed is not just left alone, it is constantly being governed, and when there is a need, it is being replaced, and proper steps are being taken. In order to govern, we have certain checks in place. It could be alerts. These alerts will trigger some actions, and these alerts could be based on some conditions, or these could be scheduled also. Now, deciding when to send an alert. So probably when a model is deployed, when a particular KPI or maybe a metric starts below a threshold, we can immediately send an alert to the respective stakeholders. When a failure occurs, we can send an alert. When there is an availability issue in terms of infra, we can send alerts to the engineering team. Similarly, we have like several criteria on which we can send alerts to the different stakeholders, be it engineers, scientists, data scientists, or DevOps, when there is a hindrance in the model operation. Last but not the least, that model auditing is also very important. As I said, that in order to make business understand the value of a model, we have to report all that model is doing. So many a times when we start, we do not pay too much attention to it, but for an organization, for a business need, these are very essential. Now, combining all of them is the CI/CD. So CI/CD basically integrates our dev environment, test environment, deployment along with monitoring. So we have our integration, continuous integration, coming with continuous delivery, and then deployment. And when all these are just automated end to end, we call it a successful CI/CD pipeline, because that is when a model is actually deriving the right value. So I will skip this part because I know I'm a bit over time selection, I'm sorry. So I will just quickly maybe give a view of a small use case that we did, and maybe how we ingested the data, what was being stored, prepared, registered, deployed, and monitored. So this data basically was coming from one of the sensors fitted inside the vehicle, and the aim of the project was based on the displacement of a particular component fitted in the wheel. If we can identify if the road is good or bad, because the kind of displacement that is going to happen in the suspension rod, which is attached between a wheel and the chassis system, we can understand, okay, if the displacement was so much, we understand that probably the road was not good. So we classified using basically maybe ingesting the data into our streaming devices, storing it, labeling the data, doing sampling, harmonization, because these are signal data. The data was not equi-sampled, so we had to take care of all that, apply machine learning algorithms on top of it, creating metrics, showing it to the business, making them understand why we think this model is performing better, showing them different metrics that if we go with 2-class classification, this is the model accuracy. If we go with 3-class classification, so and so is the model accuracy. So defining it, we had good, bad, bumpy, or cobblestone road conditions for a particular application. After we did this, we registered a model, deployed it, and then started monitoring the system. Monitoring is very much similar to what I covered, basically logging the model, trying to understand if the model has started depleting, maybe looking back into the metrics, and then iterating this process again. So this is basically a road condition monitoring app where the model is embedded, and it is able to show that, okay, based on the input data, this is the place where we have good road, where we have bad road, where we have an okay road. So basically into three classes we have defined this model, where you can clearly see these colors to indicate the quality of the road. So this completes my presentations. My presentation is machine learning engineering for production by deep learning.ai and technical data and machine learning. Then just quickly winding up with some tips to the students who are just starting fresh as a data scientist, that participate as much as you can in such events. Try to join a community of data scientists where you can, even if you are new to it, maybe you get to know those words, those acronyms that are being used in data science field. Get into the habit of reading good research papers. And when I say good research papers, you might have certain good publications, which could be IEEE, NIPS for basically machine learning. Just consider that. Practice coding every day if you are aiming to be a core data scientist, because that is when we start improving. When I also started learning, I was reading a lot, but result was not that great. But when I started practicing, that was when I understand that my performance was increasing. So that was when I started measuring my progress. So I started to understand, okay, probably a month ago when I was seeing the same problem, I was not able to solve it, but now I have the ability. This is a very important thing, that do not compare yourself with others, because they are on a different journey. There are people who have been into data science for 10-15 years, and if we start comparing ourselves with them, we will be very much intimidated. So we do not have to compare ourselves. We just have to stick on what we have in plan for us and compare ourselves to our previous self. And last but not the least, if possible, find a mentor, because they will be your, they could be your true guru, and they can guide you in the right direction. Thank you, Sulakshana. Thank you, entire team, for I think bearing this at this critical time of lunch. So thank you for to all of you.
Thank you so much. That's a lot of work actually, and I really appreciate you for all the contribution. And thanks for making it to WiDS Hyderabad 2022 conference. Thank you so much. Moving on, we have a video message from Sushmita Krishna Kumar. She's a data analyst at Bridge I2I Consultants. I'll just play it for you all.
Hi everyone, I'm Sushmita Krishna Kumar. 2 years back, somewhere around the same time, an opportunity came across my path.
Yeah, it's visible, madam. Visible. Just play.
I'm Sushmita Krishna Kumar. 2 years back, somewhere around the same time, an opportunity came across my path, which actually exponentially grew my career from there. And I have my deepest gratitude for this. To explain a bit about the opportunity that I had in hand, so one random day I was having coffee with my HR, and she just mentioned that there was this opportunity where it was a platform for women. It was a conference where they were hosting all women who were in data science, and she asked me if I would be interested. And it seems too overwhelming at the first stage, because it was just 1 year in my career, and it was a big step. And I just went ahead and said, yes, please go ahead. And within a day or two, I got a call back from Sulakshana, that is the ambassador of Women in Data Science India. Uh, she is a lovely organizer and an amazing human being. She made my transition pretty smooth. She gave me an opportunity where I could either be a panel member or I could give a keynote, and I chose to do a keynote. As and when it approached towards the conference, it was just a few days before the conference when I started curating the content for my talk. I took the help of my CEO and we worked on the content. I had to pick a content which was a bit neutral, and the story that I picked was the art of storytelling in data science. And the reason I chose this topic was because of the crowd that was going to be available at the conference. There was going to be data science practitioners, there were going to be amateur data scientists, there were going to be students, there were going to be teachers, there were going to be researchers. So I had to have a topic which was neutral and which could add value to every one of them who were attending the conference. I still remember the day of the conference. I had an early flight at 5 in the morning and I had to travel from Bangalore to Hyderabad. I still remember standing at the airport, check-in around 3 in the morning, being completely nervous about my talk. And within no time, I was in Amazon Hyderabad campus. And the moment I put the first foot in the campus, I saw a lot of people, like lots of people. And I was like, oh my God, there's so many passionate people who have come on a weekend to attend a conference, that too in data science. So I realized there's a lot of scope and potential. And there were a lot of bright minds too. And I also had the opportunity to have a conversation with different speakers who were literally senior leaders from well-known organizations around the globe. It was really my honor, and I have made pretty good friends with them. Then my talk was somewhere around in the second half, post-lunch. I was kind of skeptical because I was worried that people would be a bit sleepy because they would have had lunch. So on spot, I took a decision that I'm going to keep this session an interactive one. I took my first foot on the stage and I had a glance at this huge hall filled with people, men, women, young people, older people, experienced, amateurs, and they're all with curious eyes staring at me. And I still get goosebumps thinking about that day. I started the talk and I started with a story and then I asked a question. The moment I opened it to the audience was so interactive, and wow, I didn't even realize how the time passed by, and I even finished my 20 minutes slot. I kept talking, I kept interacting, and people kept answering the questions. And it was a course of 20 minutes, which was educational for both me and them. And I have not found such a good crowd in the past experience where I've given a lot of talks. And this conference has such well-established name and such good speakers who attend the conferences, which drives this amazing energy of crowd, which was actually add a lot of value to me as a person. After the talk, when I got done, I had a lot of people approaching me with questions. And till date, I have most of them in my LinkedIn connection. And we help each other grow till date. It's become more like a community for me, where I can approach people that I want any help from, or any particular new technology that I'm working or somebody else has already worked with, and I want some guidance, or maybe some amateurs usually reach out to me for some kind of a career guidance, or clearing some kind of a doubt or roadblockers in the career with respect to data science domain. And to all this, I would thank WiDS Hyderabad and also Sulakshana for giving me this opportunity. And I wish all of you all the very best to be part of this wonderful domain. And also feel free to reach out to me on LinkedIn. I'm always there to help people. And yeah, just feel free to just ping me. Also, happy Women's Day to everyone out there. and have a good conference. And I'm really glad that I got this opportunity to again have a word with you guys. It's my pleasure. And you guys have a good day. Bye-bye.
Well, that's the message from Sushmita Krishna. Now moving on, we have student segment this year where students of BVRIT Hyderabad College of Engineering would be presenting their data science projects. We have Dr. Aruna who would be driving the session here. She is a doctorate in the field of computer science, and she's got more than 18 years of experience in the field of teaching and published many papers in the international and national journals. She is also a recipient of Jyeshta Acharya Puraskar in the year 2019. And apart from all of this teaching and teaching experience and qualification, she is a great leader. I would like to invite her, and she would be driving the session for us.
Yeah, good afternoon to all the delegates out there. At the outset, on behalf of BVRIT Hyderabad College of Engineering for Women, I would like to thank WiDS Hyderabad for giving us this wonderful opportunity for showcasing the talents of young minds. I would also like to thank our previous speakers for giving us a very informative session. Before we dive into the actual presentations, I take pride in stating that BVRIT Hyderabad is one of the most sought engineering college for girls. The college offers 5 undergrad courses in the discipline of computer science, information technology, computer science, AI, ML, electronics and communication, and electrical and electronics engineering. We also have a PG course in the area of data science. So we all know that at the brim of this 4th industrial revolution, significant transition has been taking place from digitization to the innovation-based technology. So in line to this, BVRIT Hyderabad, we at our college, promote innovative competence among students. We encourage our students to identify the problem and come up with a proposed solution for the given problem, which is practical in nature. So students, under the guidance of the mentors, faculty mentors, undergo certain projects, and most of it are related to the current trending technologies, which are actually helpful to the novice technology users. So few of these projects we are actually showcasing now. So in this regard, now I would like to request Ms. Shruti and her team to kickstart with her presentation. Can you please come over?
Where the stop words and articles are removed, lemmatization and stemming reduces the words into the base form. The low frequency words are then removed, and since computers cannot understand English words or natural language words, the MBTI traits are converted into 0 or 1, that is the binary digits. Next, we have the feature vector generation stage, where we use count vectorizer and term frequency and inverse document frequency, where the count vectorizer will be generating a vector which represents the count of each word in your data set, and the term frequency and inverse document frequency are the frequency of your words in the document. Next, for our project, we are using the naive Bayes classifier, which works on the Bayes theorem, where every pair of feature being classified will be independent of each other. So as there is a strong relation between the type of language or the words used in the post in the social media and the personality of the person, so we'll be using that relation and the Bayes theorem in order to predict the probability of a probable personality with respect to the social media posts. So the technology stack and library used are Python, Flask, which will be used for the web application development, Pandas for data manipulation and analysis, NumPy for numerical computation, Keras and scikit-learn for supporting the artificial neural networks, NLTK, which is the natural language toolkit for natural language processing. Next comes the applications. As discussed earlier, this proposed methodology can be used to hire suitable candidates by the HR. Next is the product recommendation, where a suitable product can be recommended to a set of persons or consumers based on their personality. and in marketing, where we can choose suitable business partners in order to market our product. Thank you.
Thank you, Shruti. Now I call upon Ms. Neha and team to present their project, WalkMate.
Good afternoon, everyone. I'm Neha and my teammates are Monica and Janvi. Our project is WalkMate, a smart walking cane. We belong to the Department of Information Technology at BVRIT Hyderabad College of Engineering for Women. Let us dive into the problem statement. So globally, at least 2.2 billion people have near or distant vision impairment. And India, being the second most populous country, has the highest number of visually impaired. And there's this preconceived notion in the society that the visually impaired cannot do anything or cannot lead a normal life, which is not true. Because they find it difficult to do a lot of things, but they have their own way of doing things. One of the major problems faced by the visually impaired is not being able to navigate outside well-known environments, which also affects their ability to do a lot of things that requires them to be outside. So the main reason behind us choosing this project is blindness is one of the major public health issues in the country, and there are a lot of innovations being made, a lot of attempts being made as to how we can make the life of visually impaired easy. And WalkMate is just an attempt to make the navigation part of their life easy. And we strongly believe that if you all can come together and develop some adaptive equipment, we can let the visually impaired live a normal life like all of us. So the proposed solution is a walking stick that the user can use to navigate around outside his usual environment without requiring anybody's assistance. Some of the key features of the stick are object detection, which is a very basic feature that is used to detect objects around the user. Also, the user can send a message to his guardians in case of any emergency with just a click. He also can share his live location. The user can find his stick in case he misplaces it. We also included a feature where we use a light emitting diode and a light dependent sensor. And the light emitting diode glows in low light areas just for the surrounding environment to acknowledge the user's presence.
Here we can see the architecture of our project. Here we can see the architecture of a project. We use different modules to implement our project, such as ultrasonic sensor for object detection, and RF module is used for wireless connection between the button and the walking cane, so that the user can easily find the walking cane in case of misplacement. And GPS and GSM modules are used for emergency messages to the guardian's contacts, and an LDR is used so that the LED can emit light according to the surroundings light. Till now, we have completed phase 1 of our project, which is object detection. And here we can see the setup of our components. Now let us take a look into how the object is being detected in our first phase. So this is the ultrasonic sensor, and when an object is detected near the ultrasonic sensor, a buzz sound is given by the buzzer. So I would like to conclude by saying that with this project, we are going to build a smart walking cane for visually impaired people, so that they can easily navigate themselves in unknown surroundings, so that they can have a sense of independence. And we hope with this project, it can bring some changes in some of people's lives. Thank you. Yeah, thank you, Neha. Now I call upon Ms. Nikita, who has joined us online.
Hello, ma'am.
Are you there?
Yes, ma'am. Can you hear me?
Yeah.
Can I get a screen share permission, ma'am?
Yeah, sure. Let me stop presenting my screen.
Sure, ma'am.
Okay. So I think you have access. Do you?
No, ma'am.
No,
No,
ma'am.
no, no. Ask her to wait, ma'am.
Yeah, please wait. Give a minute.
Yes, ma'am. Yeah, now I have the access, ma'am.
Go ahead.
You can see my screen, right?
Yes. Could you put it in slideshow mode? Yeah.
Yes, ma'am. So, hello everyone. I'm Nikita, fourth year computer science student from BVRIT Hyderabad College of Engineering for Women. Today, I'm here to present our project title Forecasting on Cryptocurrencies along with my team. Cryptocurrency is a digital or virtual currency that is decentralized network based on blockchain technology. Over 50 years, many people are researching on stock market prediction with different algorithms, but cryptocurrency came less than a decade ago. Because of its high fluctuating and volatile nature, those existing algorithms aren't giving appropriate results and there is no enough data. So our aim is to do reliable predictions by integrating deep neural networks that help people who are investing in cryptocurrencies. This is a graph of prices of 4 different cryptocurrencies for a period of 1 year, and you can see how volatile the prices are. There is immediate rises and falls, and this can be handled by time series prediction algorithms with the deep learning neural networks. And that's how we found about ensembles and different algorithms like LSTM, DPAR, FB Prophet, which effectively forecast in risky times such as sudden falls. Cryptocurrency is very useful for different people because of its features, which is fraud proof. All identities of coin owners are encrypted, so you own it. Neither government nor the bank has any control over it. Next is instant settlement. Blockchain is the reason why cryptocurrency has any value. Easy of use is the reason why cryptocurrency is in high demand. Now, accessibility. There are over 2 billion people with access to the internet, and everyone can access any cryptocurrency through internet. Next is you are the owner. There is no other electronic